great to be here today. I'm going to try to take a foundation for the talk that was going to be presented and give you the information that was going to be provided there, and then apply that to some real-world deployments in the state of California here. So within the range of the discussion today, we're going to go through some best practices, and we're going to talk about how those best practices were actually put into real-world running systems. So, great to have you here. Let me explain a little bit about who we are. We supply Verizon and Terramark with virtual desktop infrastructure, and we build out both dedicated, hybrid, and shared tenant infrastructure on top of the Verizon cloud. And we'll talk a lot about how those different things run. We'll actually demonstrate them running. We've got load balanced infrastructure that runs in Miami, Culpeper, and Santa Clara, and we'll show you exactly how we've gone about securing those, passing audits, meeting the requirements of state and local governments, as well as federal. And we've also been involved with some Defense Intelligence Agency activity as well, so we'll talk a little bit about that. So that's it. So in the world that we live in, we're responsible for producing more nines of availability than systems are really capable of doing. So how do you do that? I mean, how do you actually, in effect, change entropy and go up the stack? So in our world, we spend a lot of time focusing on two principles. You build a sandwich, and the sandwich we build starts with the notion that you need multiple data centers for redundancy, and you need a distributed data system that's highly secure so that you can actually tolerate complete data center outages and still not have a diminution of service. Now, that's a hard thing to do. So the first thing you need to do is you need to have world-class infrastructure. So let's talk a little bit about world-class infrastructure. There are a few pieces that you have to come up with. Number one, you need really geodiverse, high-quality networks. Because if you're going to plan on your data centers failing, which you need to do, you need to then ensure that you have the various pathways to get back to the other data centers that will still be hopefully up and online. So that means you need to look at different threat zones, look at ways of handling that. So in the environment that we're in right now for all the demonstration activities we do for both state and local governments and federal activities, we actually run on a minimum of 3 or 4 data centers in a combined service platform to deliver content. You have to then make sure that that's fully secure. So in the theme of this conference, we need to look at the various models of deployment and show how you meet the security requirements. And we also need to spend a lot of time looking at how you actually design out single points of failure. So what we learned a long time ago, having built virtual desktops around Microsoft technologies, is that even though Microsoft would like to tell you that they can produce 5 nines of availability, that's a myth. And I think collectively across the room, you all know that that's true. You cannot take a Microsoft server operating system and actually create 5 nines of availability if you measure the year with 24/7, 365, right? 24/7, 365, 8,760 hours, I think is what it is, right? That's the year for us. That's 100%. So if we're looking for, 5 nines, that's not a lot of hours left over to do reboots, patches, right? We just look at best practices for patching and rebooting systems, that drops you below 3 nines, right? So how do we get around that? What's the trick? What's the magic to doing that? Well, you do a lot of N+1 work, and you design all the services that you produce in such a way that they're redundant. So you can take them out of service, you can reboot them, you can patch them, and then bring them back into service. And then by staggering things properly down the way, you can produce a deposit service level that is higher than the 3 nines that are inherent in the patching of OSs and rebooting. Now, how do you make that work? Well, to make that work, you then need to have really elegant load balancing, right? So load balancers probably become, if one goes back to the sandwich that we work on, the top end of that is a load balancer. And by the way, the load balancer has to take on 2 sets of responsibilities. One, global load balancing between data centers, so that services that you're advertising are actually present in multiple data centers. But then within the data center that you're in, you need to load balance the services. Okay? Now, that's all nice. That's all very good. But what happens if you're on the other end of it and you've just lost the data center for whatever reason? Power, flood, fire. You know, I had a little experience working for a very large law firm and investment bank in New York, and we had a little debate with the tape offsite storage vendor, and the tapes were not being taken off-site. And one night, the secondary chilled water from the cooling tower return pipe burst, flooded the DASD tape room and machine room. We lost everything. 25 people were fired that day. 25 people. So I was a very junior analyst at the time. I looked at this and I said, you got to plan for the totally unplannable. So how do you do that? You go do that by putting things in diverse data centers with different threats. So that flood was a very, very poignant thing as I watched 25 people pack their boxes and get thrown out on the street. So to do that, we now need to think about, if we're going to do load balancing, we now need to then end up with a distributed data set that we can access from all the data centers. And that gets to be a very, very difficult problem. So one of the things we're going to talk about a little bit today is how you manage dispersed data sets and how you can then do the requisite replication technologies for the databases that are actually maybe present within those data centers. So sandwich includes load balancing on the top end and dispersed replicated storage systems and transaction tracking systems that move between the data centers to create a very, very high RPO. In other words, a very low time to get back online. RTO, RPO, the 2 words that are actionable in that. RTO, recovery time objective, the time it takes to get it back online. RPO being the recovery point objective, about how fast you come back. But these all have to be overlaid within the context of making this secure, because pushing things out and making them more distributed tends to actually fight against security. Holding something secure in multiple data centers is harder than doing it in a single one. So the topic of today is how we actually think about cloud security and how you, when you move to the cloud, can actually pass the audits that are necessary. So let's go through and tell you a little bit about the systems that we build, the different deployment models, and then we'll go into some of the security details. Does that sound like a good topic to go after? So let's start right here. This is the way we begin. This is a what we call Solid Cloud. It's our virtual desktop service. By the way, this is not specific to the virtual desktop service. This just tells you how you actually manage a scalable workload on the Verizon Terramark cloud. And in this particular one, at the core of it, in the hexagons over on the side here, we have the Verizon Terramark network and their compute infrastructure. Their infrastructure is designed in such a way that you can kind of buy it by the drink. You can buy it by the resource for a year, or you can set it up as co-location. In this particular case, when we do this, we actually have people to trial these type of systems. We do a multi-tenant shared cloud hosted on top of their eCloud offering. So this lets someone be provisioned into the system. Our system takes about 15 seconds to provision a new person into a system like this. And this lets them test the notion of moving their desktop to the cloud and looking at the viability of various application types from in there. And we have a very, very diverse catalog of applications that we offer. That never is a deployment strategy for large organizations, departments. So as we go forward, the more likely scenario is that we will actually end up in a truly cloud-hosted private instance. And in this particular case, we'll have one or many Verizon Terremark data centers, our software, and a Verizon MPLS network that actually spans across the data centers and delivers the connectivity to the individual sites that need this. And this, again, is 100% private, nothing shared. Really is the question of whether or not the economics and security can be matched to your needs to actually place those resources in a Verizon Terremark facility. And we can come back and talk a little bit about that, but that is a private one. But one of the things that we've learned in doing that is there is a huge concern on the part of many of the customers that we work with about data at rest. Data at rest and the policies therein are really critical to most security audits. So with that, we ended up designing a system that allowed you to blend your cloud and your premise resources into a hybrid. We call this a hybrid on-site and Terremark solution, where we actually design a private MPLS network that spans the various sites you have, and we build compute infrastructure that can be placed in the customer network or customer DMZ based on what the policies look like. And so on this side, let me go back one, we end up basically taking what we call an edge pod, which is a stack of servers that actually serve as a compute unit, and we run the various services that previously had only been run on the cloud, now are run on-prem, and therefore they're 1 or 2 milliseconds latency away from the actual data sets that they may be operating on. Lets the customer actually use the same data at rest policy that they have, because the data doesn't leave the site. And other supporting resources are available from the cloud, all the management layers, the monitoring, the software license management, all those things. So you can blend these two. It gives you kind of a blended hybrid view of the world, and it gives you a lot of flexibility, and it may allow you to take the first step in a cloud deployment, where you actually only do a portion of it on your site, and a portion of it is coming from Verizon and Terremark. So those are kind of the three main deployment models that we find across agencies, departments, and divisions of other operations around the world. I would tell you that if I was looking at a percentage here, everyone tries it on the shared hosted tenant so they can kind of kick the can a little bit and see what it's like. Many of them deploy the second one, and then many then go to the next stage where they do a hybrid deployment where they have some on-site and some in the cloud. So let's take a look at some of the base questions that were seminal to this particular talk today. The first question that really comes up when you think about security and moving to the cloud is when and what do you move to the cloud? So, those are kind of really basic but very apropos questions to ask. If I were to look at the current RFPs, RFIs, tenders, in the state and also at the federal level, there's a big thing that happened at the beginning of the Obama administration, the authoring of a document called FedRAMP, which defines new standards for actually not building dedicated resources per department or per agency. And so that one implies that you're going to move everything to the cloud. Okay, and we all know that that's not going to happen right off the bat. That isn't safe and sane. So what we find is that most of the organizations we're serving right now are moving some form of their desktop to the cloud. And they're looking at ways in which they can believe that that is a fully secure way to go forward. They're trying to extend the life of old, tired XP boxes on their desks and find a way to deploy a Windows 7 experience even though it may be delivered on an XP box that's currently sitting there. Another very popular thing that we're finding, especially on the federal side, is the use of zero clients or thin client devices. Those things are all coming down in price, so that those become kind of a disposable point of display. And then we have, you know, an eruption of iPads, Android pads, and those all present huge data security risks for most organizations. And so the question comes, if that is the style of BYOD device or others, how can one actually incorporate that into your design? And in that circumstance, the idea of moving to a virtual desktop in the cloud, which can be actually displayed or be the new 3270 terminal of the 2000s, you know, works really well because the data at rest is not present on the iPad or Android pad. Now, not all people love the experience of an iPad rendering a character-based, keyboard-driven application. So there's a gap there, and if you are going in that direction, the single largest factor that we have found for large-scale deployments is the inclusion of keyboards with the iPad. Logitech and others, I think Logitech builds everyone, but it's supplied by 12 different companies with the Logitech innards in it. You know, gives you the ability to at least have a keyboard experience and not have kind of the difficulty there. If you use some of the new, most modern iPads with a Retina display, you know, that doesn't, I'm 58 years old and my eyes don't work real well for the Retina display, even though it's very nice because its resolution is so high. So, you know, some of those things about deployment on those devices need to be considered. So the first thing that people tend to move to the cloud, and I think this is present in California where there's a common need to move the mail systems into a shared resource or shared tenant infrastructures. Once you've got that done, what comes along with it is, of course, the question of whether you're looking at unified communications, things like Link. Are you actually using SharePoint? Are you going to then have a hosted SharePoint instance? Because those all kind of tie together into a solution that becomes kind of interesting. We've done deployments where we actually do Link VoIP on top of these, so the iPads and all those actually become phones in effect for people. It's not fabulous, but it's a workable way to think of it. But if we start from the security perspective, the best part about this is all the data is still completely contained in either the premise or the data center that you've chosen or the cloud that you've chosen. So first, move all your kind of supporting services of mail, SharePoint, Link. Next, move your desktops. As you move your desktops, then there's usually, for most organizations, about some 300 to 1,000 custom-made apps that have been done. You then need to take a hard look at that moment and think about doing application sequencing to make it easy to publish those apps. And we'll talk a little bit more about that, but let's just say that you don't want to end up with 100 or 200 gold images. You want to have, you know, 1 or 2 gold images and actually publish applications into that. Very few of the people that we work with right now when they get out of the testing phase stay in any multi-tenant infrastructure. Multi-tenant proves to be just much too difficult in terms of what's there. The suitable applications, we're involved with almost every class of application there is. We have not found anything yet that we cannot do, and I'm talking about working for Autodesk with AutoCAD and Revit, huge 3-4 gig models. They give them amazing stuff. Working with Adobe. Adobe's one of our customers, and we're doing work with Photoshop, which a lot of people would not believe you could actually run well in a virtual desktop environment. Runs actually extremely well. There are new things coming this fall in the way of GPU virtualization in virtual desktops that you're going to see. I can only tell you that it's pretty amazing when you look at what's possible. So that's kind of on the highest end. if one goes down to the bottom end of just straight office apps, they run really beautifully in a virtual desktop. So, those are, I would say right now, I have not found anything that is impossible to do. Probably the worst thing I've seen is some of the really high-def video conferencing apps that people have built that are up and doing 1080p video conferencing. That requires a very significant network to the endpoint. But if you have the resources at both ends, on the servers and on the endpoints, that is possible to do that. So the question then comes is, how do you integrate security into this? What are the fundamental pieces that need to be there to make this type of infrastructure work? And there's one kind of magic bullet that makes most of this possible. So for all those of you that have worked with Microsoft's Active Directory Federation services, it was called the Geneva Project if you were old and waiting for it to become commercial. ADFS allows for a way of actually keeping your Active Directory permissions and authentication under your control and then delegating that authority to a cloud provider. And so ADFS is a very, very critical part of actually designing something that pulls together your infrastructure and a cloud infrastructure around a common single sign-on. So ADFS is a great thing to take a look at. We use it pretty extensively in our world, just as a consultancy. We actually run against Microsoft's Office 365, but we use ADFS, so all the credentials are actually managed in our AD instances and then authenticated, which then allow us into SharePoint, Link, and Exchange. Then the next thing that comes down is you all have your favorite toolkits, the toolkits that allow you to manage your infrastructure. The question comes, are those toolkits going to be applicable to an environment that cuts across multiple data centers that are not under your sole control? That's a big question, right? Two tools that we make extensive use of is one looks at what Microsoft is developing with System Center. System Center has become much more capable. It actually manages Linux-based resources now, which it didn't before, monitors that. The environment we come from actually makes use of something called ZenOS, and that's ZENOSS. I don't know if you've ever looked at that. That is a true multi-platform, multi-tenant infrastructure that monitors things. It was actually developed by a large carrier that is not represented in this room. And then the team that built it, when that group acquired their company, turned around and came forward and asked to be have their shackles released, and they then became a open source project on the net. It actually is the infrastructure that manages and monitors all of Rackspace, just as an example. So that's something to take a look at. It cuts across all platforms, Debian, Ubuntu, Windows, all through. Then if you sit down and start to look at the agreements that you need to have in place as you work between organizations, you have to then make sure that there's a very clear set of responsibilities. The speaker that was supposed to be here is actually dealing with a data spill, right? Whose liability is that, right? Who's taking responsibility for it? Big issues there. Those are big parts of the contract details you need to work on. The minute you actually have some of that critical data that is off-site and housed elsewhere, those liabilities are significant, especially if it includes HIPAA compliant information. So the amount of should we say, negative financial impact there is significant. As you move forward, most people who have a modern view of the world say that everything is going to the web and everything will be a web-enabled application. Haven't seen it happen yet. There's a lot of web-enabled apps, but I will tell you there's still a lot of very heavy client apps, and virtual desktops tend to be one of the tools with which you can do that. So, you know, ending up with good standards that give you, you know, applicable ways of presenting the content both on mobile devices and on virtual desktops and physical desktops tend to lend you to think of the world from the perspective of what is the data at rest, especially when one thinks about data at rest on mobile devices, because there's a huge liability involved with that. So the next question that comes up when you're in a planning cycle is, okay, we're going to go to the cloud. How do we get the data sets that exist out there into the cloud? What is the onboarding process? This is one of the details in the project planning that we find is overlooked frequently. And in fact, if I was to look at projects that we've come in and kind of rescued, every one of those projects had failed to actually design a solution that had sufficient time and tools to build the onboarding into the timeline. And then last but not least, you have to look at the long-term management of your directory services, how you're actually managing ADFS, and making sure that that's redundant enough so that you have multiple paths back to your AD. So one of the things that is fatal within Active Directory Federation services is if you only have one head end to come back into, if that goes offline, all of those mashup services that are depending upon ADFS to be there for authentication immediately go offline for you. So designing redundancy and load balancing into ADFS service points in your network, presenting that to any third parties that you're actually going to host services on is a really critical design phase. So those are just a few little watchwords. I'd like to just kind of go through a couple of the designs for some of the larger systems that we've deployed and kind of provide some takeaways. I think this would at least give you some actionable intelligence to take away from this. Does that sound like a good use here? So this is our typical N+1 infrastructure. This one here is designed in 4 data centers. The upper one is Terramark Santa Clara. There's a rather remarkable facility that Terramark has outside of Washington. It's just outside the blast radius of Washington, 65 miles to the west, which happens to be the magical dimension of what they think of a hydrogen bomb going off at the Washington Monument. And that one is called Terramark Culpeper. There's another remarkable data center down in Miami that is ground zero for Terramark's elegant designs. And that one actually is in a hurricane path and has never gone down. We've been operating out of it for various services for over 4 years now and never had an outage, which is a pretty amazing thing through some very, very nasty storms. And then the fourth site is Terramark Denver. And this is a facility that's really growing out in the Terramark family. There are about 60 data centers that are within the combined Terramark and Verizon infrastructure around the world that have a variety of different services. All the ones that we have here have a combination of both co-location services as well as eCloud. The ones that in this particular design, this came up before eCloud was available in several of them. And it has a replicated storage system that cuts across all of these data centers. We make use of a technology that comes from a company that's based in Chicago called CleverSafe. CleverSafe comes out of the defense intelligence industry. There has never been a data breach, a data dump, or leak from a CleverSafe infrastructure. It is actually used even to put top secret information in plain sight. It works around the idea of sharding files into pieces, so you could think of it as RAID for the net, and they are really accomplished in what they do. So we have kind of been on the forefront of taking them into a commercial and non-secure data environment for usage by state and local governments and non-defense related agencies. So what this gives us is the ability to present a single file system that is present in all 4 data centers. That single file system is actually presented and has recovery objectives and recovery time objectives in under 10 seconds. So that you literally are at risk with data, in write state for about 10 seconds. So that means the RPO that you're looking at, the recovery point objective that can be achieved with such systems is 10 seconds. That 10 seconds is a remarkable condition. That's a condition for endpoint computing that has not been achieved by most anyone that has not been secure. Why is that important? Well, it now gives us the ability to take a design such as this and design the capacity for 100% of the system to be upgraded if it's only up in 3 of the 4 data centers. So this is an N+1 architecture. When we have smaller systems, when we get down to 2 sites, the N+1 of course is 100%. When you get to the next level up and go to 3, you have a 50% overhead in N+1, and when you get to 4, it's 33%. So those are kind of some interesting data points to think about. Now, this only works well if you have something at the core of this, which is a great multipath network. So in these designs, they all make extensive use of MPLS as the core private network amongst all the sites. But then there's a fully redundant plane right behind it that is all VPN based that shadows the same network. So again, lots of geodiversity of route, geodiversity of fiber path, and also geodiversity of electrical grid. And those are the things that are necessary to build things that run all the time. When we do our storage system that we mentioned, what we did is we built a system that would facilitate the onboarding of data. If one takes a look at the average laptop or desktop that people have, there's a tremendous amount of the work product, unstructured data, not the structured data, that is existent on those particular machines. And so when you turn on a virtual desktop and that virtual desktop doesn't have access to that content, you have a very hollow experience because people don't have access to the information that they need to be able to deliver that. And so in this particular case, the way this works is it allows you to install this cloud filing system on the laptop, move the data into the cloud filing system, and then from that point forward, the content is actually available on the laptop, in the cloud, and if it happens to be from a local site within your network, it's available there as well. So this provides a great path forward because no one does a knife edge cutover into the cloud or into an on-premise infrastructure. So let's give it just a visualization of what that does. This is a view of the world. I'm now looking at a file that we were presenting here. We were looking at the data centers that were present in this. Let me bring this up. So this is that typical Foresight arrangement. We have San Jose, Culpeper, Dallas, in this particular case in Miami. Replicated storage amongst all of them, but also compute available in all those. This was done for a Fortune 10 company. And it allows us to deliver this, and where our target was 5 nines availability. That's what we were working towards. Okay. So we're working on this file. This file becomes very important to us. We say, gosh, I really need to save it here. And so what I'll do is I'll save it, and I'm going to name it version 5 here. And I'm saving it on a cloud drive, right? So I'm going to save that. If you look down here, you'll see a little G, and the G is the cloud drive, and it's lit up right now while it's actually writing that file. This is about 4 meg, I think, or 3.5 meg file. When that light goes off, that will be a complete write. to the cloud. But you say, how do we know this, right? How does this, how can we be sure it's the lights out now, okay? We then say, let's go over to the other context. Let's go to a different machine. Let's look at that particular file system. Go to the marketing one, and there's version 5 of the file. And so I'm going to go now and say I want to look at that because I just worked on it. By the way, everything we just did were being done on virtual desktops in the cloud, both those instances. Yes, question in the back?
At any given point in time, can you tell me where in your cloud mesh, at which site my file exists?
It doesn't exist as a file in any of the sites because the way it works is we shard the file into 16 slices, okay? So we take the file, we actually inflate it by 1.6, and then we actually slice it into 16 slices of that 1.6, which has all of the mathematical equations in each of them. And then that gets sent out. We're actually running in this particular environment in 8 storage data centers, by the way, separate from Terramark.
So at a given point in time, it could be in 5 different locations across the US, pieces of it.
So what it's in is actually in 8 different data centers. We actually write 2 of the shards to each of the data centers. And we need a quorum of 10 of those slices to be able to read the file. To write the file, I need a quorum of 12. And so that's how it works. It then provides really, really fast performance both on write and on read because it actually issues read commands to the whole thing. Now, on top of that all, we're doing AES 256-bit encryption of the file before it gets sharded. So it's very locked down.
Where is the sharding taking place?
This taking place on, let me go back here, sorry, 1 second. I realized in saving the file, I took the Seminole drawing off the screen here. Let me pull that up here. So the sharding occurs in a combination of the cloud filing service and the client. All the keying is done on the client. And it passes those down into the cloud filing service, which then geodiversity writes it to the different data centers. Just as a reference, relative reference, the defense intelligence agencies that use this store over an exabyte of capacity in this. In the world that we live in, where we actually want to go see something that's productive, Shutterfly is the largest commercial user of it. And when they're in their peak write phase, they're doing a million writes an hour in the system. So this is pretty interesting technology, and it's, as I go back to that sandwich I told you about, global load balancing on the top, load balancing, and then a geodiverse filing system on the bottom, and CleverSafe is the foundation for that. Gentleman in the back there.
I have a couple questions.
Sure.
One, are your data centers SSA 16 or higher?
Yes, they are.
And I know you're talking about the defense data that you're housing, but is it PHI, HIPAA, FTI, anything like that?
I have some really deep technical people on my team that could speak at great length about that, but let me just say that the data centers that the principal data centers that we do the fully secure operations from are the Miami Terramark site and the Culpeper, which are both DICAP certified. Within the federal government, they qualify as FISMA high. Now, the keying and all the things that you're asking about, I have much brighter people than I, and so I can't even begin to tell you, exactly what the keying standards are.
Because I think for the public sector, it's about privacy, and if you go through a compliance audit, the first thing they want to know is if you're breached and you're in 16 or 8 or 12 data centers, I want to know if that data center is breached, was my data breached?
Yeah.
And if you can't provide accountability for that,
well, we can't.
It's not viable.
So let me backtrack. The reason why that is not the issue is you can't construct the file without having 10 slices. This is absolute garbage.
Right, but proving it on a compliance audit is really the.
Oh, yeah.
Which I agree with you, there's no way they're gonna be able to access.
No, it has been proven, and it's been proven by people who care greatly about this. So, I'd be glad to, if you want to grab my card, I can give you some pointers to the people that actually have certified those things.
Dovetail off of what he talked about, has there been any movement in the issue of that the feds and the states can come through with a warrant or a warrantless search of your data or our data and instruct your company, or not, or you don't even have to be instructed, you are not obligated to inform us of that warrantless search or warranted search?
The issue that you brought up is an absolutely critical issue, and one of the reasons why this type of file storage system is used by people who are highly concerned about that. In our previous life, we worked for a lot of very large hedge funds, okay, who were very concerned about that exact point. Turns out that the one reason why they kept some of the shards under their direct control was so that under no circumstance could any of their service providers actually reveal the content.
So you slice and dice it 8 to 10 times, and you keep a couple of shards and distribute the rest.
You got it.
Okay.
So that's exactly what happens with the defense intelligence agencies and the things they send to China. They keep, I mean, just to put it in really simple terms, there's 16 shards. They leave 9 of them in Asia. They keep 7 of them in the US. So the only way that anyone can construct a file is actually with secure access to the 7 that actually live in the US.
Okay, but from a legal standpoint, are you aware of any movement in that arena as far as the legal requirements?
The legal requirements are ugly, and that is that the judge presents an order or writ that you have to turn over the data, you have to, but the beauty of this system is the data means nothing, right?
Yeah, but I mean, you're still dealing with the potential. That's what I'm saying.
No, because it literally, you cannot construct the file. You know, it's the same China, you know, US.
I work as a penetration tester. If I want to, I can reconstruct the file.
I'm just,
Okay, I know what I'm saying. That's why I was asking from a legal perspective.
yeah.
You know,
But
because
from a legal perspective right now, Verizon, Terramark, and all that could very easily be presented with, you know, an order to turn over those things. And that is, you know, one of the reasons why some classes of organization really treat data at rest as a tremendous liability, right? So, I mean, the point that he's bringing up is, you know, something that one should light up a lot of people's concerns. Other questions? Yeah.
All of your MPLS links are all encrypted as well as the MPLS.
They are, the gentleman that can talk a little bit more is sitting right behind you, okay, we can talk a little bit about that. So, you know, every one of the large systems that we do has a very significant private network that is MPLS based, that is Verizon provided, okay? Then sitting right beside it is the place where a lot of people think is highly vulnerable, which is the VPN that runs in parallel with that. So, you know, the attack that you have to check on is the quality of the VPN termination equipment and how well it protects your against. So, because everyone plans for failure of the network, right? And the way they do that is they build a parallel network. You just have to make sure that you have physical security on those devices. And so, you know, if you look at any of these Terramark data centers, getting physical access to these is a minor miracle, right? You have to truly be, right. So, you know, that's the one that happens there.
I got a question for you.
Sure.
The 5 nines that you have,
Yeah.
that's stated, does that SLA cover the on-prem stuff as well for 5 nines, or how does that work?
Well, we run into some interesting problems because we don't find that some of the on-prem data centers have the quality of power and air conditioning that equals the Terramark facilities. So our design center is to go to 5 nines. The Terramark actual guarantee is for 3 nines. But in our world right now, you're going to judging us on 5 nines, not from the perspective that you're going to try to recover cover on 5 nines, but you're going to judge us on that. So I'm trying to be blunt about,
So the SLA states 5 nines?
now, the SLA states 3 nines because that's what the base infrastructure is. And most people, under the normal mathematics, cannot prove that you can take multiple 3 9 systems and make a 5 9 system out of it. We can, you can trade the math, but the actual legal contract from which you would be buying services from Verizon Terramark would be 3 nines. But I'm just saying, in the world of trying to do desktops, where everyone's not productive, you know, when you're offline, you have to be running at a completely different level. It's stepping up to a different level altogether. So those are some of the things we've experienced in doing it. We've passed some very, very thorough audits by staff that has broken through and tried to do all the penetration testing that you could imagine. I can tell you that the base infrastructure that makes this all possible is the super quality of the network and the super quality of the hosting and co-location capabilities. When you start with that really being sound, you have the opportunity to succeed. If you have, shall we say, variability at those 2 layers, it's almost impossible to overcome that. So really appreciate the opportunity to come and fill in today. I hope this at least gave you a little insight into kind of an interesting use of the Verizon Terramark infrastructure and kind of an interesting set of workloads. Our standard implementation takes about 25 virtual machines to get the base, and our large-scale deployments have been in the 40 to 50,000 seats. So these are ones that have to run all the time. Thank you for your time.
I would like to say one thing for me.
Sure.
Dismiss here. If you would like to come by the Verizon Table in the Solution Center, I have these colorful folders on the table, and inside there I have placed an executive overview of our data breach investigative report that we do every year. We put a lot of work into this report, and it's highly recognized in the industry, so I suggest you come by and pick up one of these colorful folders, and inside you'll also find, excuse me, there's information on the cloud that Verizon offers and on our security services. So just please stop by, pick up some goodies, and pick up a folder. Thank you very much for being here.